Alright, so today we are going to introduce to you the Fibonacci numbers and the golden ratio in our nature and our environment. So we are going to provide to you some examples of this, but first, let us define what is the Fibonacci sequence. What is a Fibonacci sequence? So Fibonacci sequence is a series of numbers in which each number, which what we call the Fibonacci number, is the sum of the two preceding numbers. As we observe and look around us, we can encounter different representation of our Fibonacci numbers. Okay, so here are some examples of the flowers that represents the Fibonacci numbers. So the first one is calla lily. Next is Otelia, the European frogbit, Gumamela, purple cosmos, Mexican sunflower, and daisy.
The example that I chose for the Fibonacci sequence is a tree branch. The formation of division of tree branches can also be perceived as following the Fibonacci sequence. A primary stem will continue to develop until it gives birth to a branch, which makes two development points. The other new stem remains inactive as one of the new stems splits into two. For each of the new stems, this pattern of branching is repeated. The sneezewort is an excellent illustration. This pattern can be seen in algae and root systems. So this is the tree branch that I drew. This represents a Fibonacci sequence. These are the numbers of Fibonacci. So this is how it goes. Number 1, because it has only one branch. 2, 4, 1, 2. 3, 1, 2, 3. 5, 1, 2, 3, 4, 5. 8, 1, 2, 3, 4, 5, 6, 7, and 8. And 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 11, 12, and 13. And that is how it goes.
The example that I chose for pattern in nature is my tabby cat, Nala. Scientists report in a study published in Nature Communications that the genes that set up the tabby patterns develop in the skin cell of a kitten before the cat first formed. Under a microscope, the early skin cells appears like tabby stripes. This is something that has never been seen before in embryonic cells. DKK4 is a secreted molecule, a messenger protein that sends messages to other cells. Cells with DKK4 will turn into the dark spots that give tabby cats their name. Mutations, on the other hand, often happens and lead to different coat colors and patterns like white spots or shorter stripes. Changes in color can also happen, a coat that is all black. In 1952, Turing represented a mathematical way to explain how pattern may develop independently. His theory called reaction diffusion said that system could self-organize during development if there were molecules made by genes in cats called activators and inhibitors that move from cell to cell at different speed or diffused. According to the mathematical explanation, the system would work out independently if an inhibitor moved farther or faster than an activator. In the case of tabby cats, the DKK4 acts as an inhibitor, but the gene that activates it is unknown.
The example that I chose for the Fibonacci sequence is the spiral galaxy. In the universe, there is a type of galaxy called the spiral galaxy. Spiral galaxies are essentially galaxies that looks like spiral and have a little arms. The Milky Way is a spiral galaxy. And the question is, how does Fibonacci apply? In spiral galaxies, the arms follow the golden spiral. The golden spiral is a spiral that shapes follow the Fibonacci sequence. So it grows out on the spiral, the inside starting at 1 point, then 1 again, then 2, then 2 and 1, it's 3, and the 2 and 3, so it's 5. And this golden spiral can be found in the shape of the arms of galaxy if you look closely and do the math. The spiral may not be perfect, but it's clearly evident. It cannot be told if it is a perfect spiral because we cannot measure a galaxy, but on paper, we can measure it and see the size of that, possibly finding an answer.